Hello, AP Stat students, Mount Hood students. This is our last video on chapter 27, the last chapter. And I've got my FRQs from the Google Classroom up in another browser. The AP Stats Quiz A, chapter 27 from our book. So bring that up while you're watching this video. Get out your pen, pencil, calculator, and we're going to be referring to that PDF of those FRQs from chapter 27 on the Google Classroom. So have that open when you're watching this video, okay? Okay, so chapter 27 is totally different from chapter 26, moving on from the categorical data, the chi-square stuff. And what chapter 27 is about, it's actually nothing new necessarily, but we're gonna talk about the two variable data analysis, which is the scatter plots, the explanatory, the response variable, make a scatter plot, and then the line of best fit, put that on there. You remember that unit with the R squared, the line of best fit, the slope interpretation, R squared interpretation. Okay, that's our chapter 7, 8, 9, that stuff. We're gonna combine that with the second semester stuff, with the confidence interval and the hypothesis test, okay? And specifically, we're gonna do a confidence interval and a hypothesis test on the slope of the line of best fit of that regression line, that slope, that for each additional x, y increases or decreases by the slope. And so what we're going to do is we're going to find a confidence interval for the true slope. And we're going to do a hypothesis test to see if there is or if there is not a linear association. Are the points linear or not? We got a hypothesis test for that. What is the true slope? We've got a confidence interval for that. So you could imagine taking a sample, and I think the problem we're going to look at has high school GPA and then first year college GPA, and those are the two data sets. Okay, we have but a random sample of data from first year students was reviewed to obtain high school and first year college GPAs. All right, so it doesn't look like this is matched pairs. It's, oh no, yeah, it is. It is like, yeah. So each data point is that one person's high school GPA on the x-axis and then freshman year college GPA on the y-axis. So that's our data, okay? And that's a random sample of data from first year students. And then you make a line of best fit on that, okay? And it was a random sample of how many pieces of data there? 16, okay? So you have a random sample of 16, make the scatter plot, and then do your linreg A plus BX and put your line of best fit on it, okay? Now, is that the true line of best fit for all first year college students with their high school GPAs and their first year GPAs? Is that the true line of best fit? No, that's the sample line of best fit. That was our sample of 16, our 16 dots. That's not the population, it's a sample of 16 and we put a line of best fit on it. So that's the sample slope from the sample line of best fit. Now, is that sample slope close to the true slope for all freshman first year students? Well, maybe it might be close if it's a good random sample, but is it the true slope? Probably not, right? If I took a sample of all first year students and got all their high school GPAs, all their freshman year college GPAs, then made a new line of best fit, that would be the true population line of best fit with the true population slope. But we're just taking a random sample of 16. We're getting a line of best fit, and then we're getting a slope. It's not the true slope. So what are we going to do? We're going to reach out from that sample slope, and we're going to try to capture the true slope in a confidence interval. And that's chapter 27. Okay. Okay. So here's what we're going to do. We're going to kind of just use this chapter 27 quiz A and just do a bunch of stuff with it. Okay. And the first thing we're going to do is put the data into our calculator. Okay. So get your data out and go stat enter and clear out the list. And actually, I think that was my phone. I got to be right back. Sorry, guys. I can't pause. Be right back. All right, thanks, guys. How about that? I don't know how to stop the video, so bear with me here. You guys are good. Okay, so putting in the data. So I'm going to put the explanatory in list 1, the response in list 2. And in this case, the explanatory would be high school GPA because high school comes first. So we're going to see if the high school GPA, all right, here we go. You guys are putting it in, right? You're putting the 3.82, the 3.9, putting it into list 1. Great. All right, we got my high school 16 pieces of data. Now in list 2, I'm putting the freshman year GPA, and it's got to go in order. Make sure you're matching it up. These are the points on the scatter plot. You guys are entering them into list 1, list 2. I believe on the Albert assignment, it does have you do this. It just gives you the data, and you're gonna have to get everything from the data, okay? All right, there we go. So I've got everything in the data, or in a list, all the data in a list. Great. Okay, now, oftentimes, most of the time, they're just gonna give you all the stats you need on this in like a computer printout, and we're gonna talk about how you read that. But if they don't, if they just give you the scatter plot data, the list 1, list 2, explanatory response, here's how you get everything you need. Okay, now I'm gonna first make sure my diagnostic is on. If you go to catalog, which is second 0, and then go to the D's, and then go diagnostic on. If you want R and R squared, you've got to do that. Diagnostic on, enter. You guys might remember doing that. Okay, now you don't have to do it again unless you reset your calculator or take batteries out. Okay, so I'm going to show you guys the 2 commands. Once you got the explanatory in list 1, the response in list 2, go over to stat, test, all the way to the bottom. Here are the 2 commands. There's linreg, linear regression, the regression line, linreg t test, that's for your hypothesis test, and linreg t int, that's for your confidence interval. So these 2 commands, linreg t test and linreg t int. Okay, why don't we first make a confidence interval? Okay, let's do a confidence interval here. Okay. All right, so we're gonna go linreg t int, enter. All right, so the X list is in list 1, the explanatory. The Y axis, the response, is in list 2. And always keep that frequency 1, never change that. Why don't we do a 95% confidence interval? That regression equation, that'll throw, if you put like y1 in there, that'll throw the line of best fit equation into your y equals, but you don't have to really worry about that. All right, what does it give us? The linreg t int. Boom. Okay, you get the confidence interval. And what is this for? This is for the true slope, okay, the confidence interval. Then it gives us the b, that is the slope. The b is your slope. The degrees of freedom. Okay, here's one big thing. For the linear regression stuff, the chapter 27, confidence interval and hypothesis test for the slope stuff. Okay, what model are we using for our interval? Which model? Normal model, t model, chi-square model? And because we're talking about slope, we're only talking about slope, it's numerical slope. So we're going to use the t model here. And remember, the t model is a family of models. That's the one we use for means. And it changes depending on the sample size. And then you denote it by its degrees of freedom. So the degrees of freedom for these chapter 27 linear regression ones is n minus 2. So that's an important, jot that down. Degrees of freedom is n minus 2, not n minus 1. When you're doing chapter 27 confidence intervals and tests for the slope, n minus 2 is your degrees of freedom. Okay, and that's why it says 14, because it's 16 minus 2. 16 pieces of data, 16 scatter points on the scatter plot, minus 2 is 14. This S, that's the standard deviation of the residuals, the standard deviation of the residuals. Okay, that's what that S is. The A, that's your y-intercept. That's your A. You can see the y equals A plus bx up there. A is your y-intercept. Keep going down. there's your R squared, and there's your R. Okay, so that's for a confidence interval. That's everything you need. You got your confidence interval, you got your line of best fit equation, you got your slope, your y-intercept, your degrees of freedom, your R squared. Okay, now let's just do Lin-Reg t-test while we're at it. Okay, now if you go back to stat test, Lin-Reg t-test, let's see what that gives us. Enter. So again, explanatory in list 1, response in list 2, and then you could do your like less than or equal to, greater than, less than. This is for the alternative hypothesis. Okay, and we'll talk all about this. I'm just going to show you what the calculator gives you. We'll do a two-tailed, a not equal to two-tailed, calculate. All right, what does it give us? It gives us the t-score, the test statistic. It gives us the p-value. It gives us the degrees of freedom. And then it gives us the line of best fit equation. S equals, that's the standard deviation of the residuals, and then R squared. So everything you need there, okay? Okay, now the thing is though, oftentimes, you're not gonna have to put everything in list 1, everything in list 2, do Lin-Reg t-int, Lin-Reg t-test. Oftentimes, they're just gonna give you the printout, right? So if you guys go to that FRQ now, and you can see the college admissions quiz A, chapter 27, and then see how they gave us the printout. Let's kind of look at that printout here. Okay, we got a scatter plot. It looks like it is you know, moderate to strong, positive linear association. Got the residual plot, no pattern. Great, it's linear, has a linear form. It has a histogram of the residuals. For the conditions, you're supposed to make a histogram of the residuals. They should be unimodal symmetric, and these are. Okay, those are the 3 graphs. Okay, then it gave us, on the left side, it gave us R squared. Never worry about that R squared adjusted. Always take the R squared. You could square root that for R. It's got that S equals 0.2118 again. That's a standard deviation of the residuals. It's got the degrees of freedom. Great. Okay, now that source sum of squares df section, you can skip that. We're not concerned about that at all, okay? That's not covered on the AP curriculum. But if you go down below that, it's got the variable, the coefficient, the standard error, the SE of the coefficient, the T ratio, the probability. Okay, this is what we want. This is important. And we're only looking at the high school GPA row. And you guys are looking at this with me, right? So why are we only looking at the high school GPA row? Well, that's the slope row. And remember, we only care about the slope in chapter 27. We're finding confidence intervals for the slope. We're doing a hypothesis test for the slope. Okay, so that 1.30527, that's the slope. Okay, and then right above that, the constant coefficient, that's the y-intercept. Okay, the 0.1993, this is an important one. The 0.1993, the standard error of the coefficient of high school GPA, that is the standard error of the slope. And you're gonna have to use that when we make our confidence interval, that standard error of the slope, okay? That 0.1993. The T ratio, oh, that's our test statistic. That's our T-score, right? And that was right off our calculator. We had that same T statistic. Okay, that 6.54 right there, 6.54, 6.55 on our calculator. And then finally, that the probability, it says is less than or equal to 0.001. That's our p-value. And on a calculator, it said 1.2955 times 10 to the negative 5. That's that less than or equal to 0.0001. Okay, so you got your p-value, you got your test statistic, you got the standard error of the slope, that's important, that 0.1993, and then you've got the slope, and you got the y-intercept right above it. Okay, so again, you're often just gonna get the printout. You're not gonna have to press Lin-Reg t-int, Lin-Reg t-test, although you could if you put the data into list 1, list 2. Okay, great. Again, I just want to point this out in your Albert homework. You're going to have to be looking at a lot of these printouts and understanding how you get information from them. So I will just say a good place to look is page 672. It's the end of chapter 27, and check that out. It kind of breaks it down, everything in a printout. Okay, so page 627 in your book, or excuse me, 672 in the book, end of chapter 27. That's, if you, in your homework, you'll get those printouts. That's what they look like. Okay, everything broken down. Okay, great. Let's actually do a confidence interval now. Let's do a 95% confidence interval. We've got our sample slope, right? The slope from the regression line, just from this sample, was 1.30527. Now, is that the true slope for all students? No. But let's reach out and try to capture that. So we are going to do a linear regression T interval for the slope is how you would title that. A linear regression T interval for the slope. T model, we're using the T model. And the degrees of freedom, n-2, not n-1. A linear regression T interval for the slope. Okay, now how do you make a confidence interval? Well, it's the point estimate, right? It's the sample thing, right? The sample proportion, the sample mean. In this case, it's going to be the sample slope. Okay, the sample slope, which is like a lowercase b, plus or minus the critical value, which in this case is going to be a t-score. That's how many standard deviations are reaching out. Times the standard deviation or the standard error of the slope. So here's our confidence formula. That lowercase b, actually, that's our slope, our sample slope. We would have beta. It would be beta, capital beta for the population, plus or minus the critical value, how many standard deviations you're reaching out, times the standard error of the slope. Okay, what is our sample slope? And if you look at the printout, or you look at your calculator, it is 1.30527. Plus or minus the t-score. Okay, you're gonna have to find this in your homework. It'll say, what is the critical value, the t-score, okay? And here's how we can do that. That's basically how many standard deviations are we reaching out to be, and was it 95%? Double check that. Create, 95% confidence interval, okay. So to be 95% confident, that's 2.5% in each tail. So we're going to do inverse normal 0.025. Now remember, you have to give the degrees of freedom, and it's going to be, the degrees of freedom is n-2, 16 minus 2, 14. Okay, and you don't want to say inverse normal, excuse me, you want to say inverse t, 0.025, comma, 14 degrees of freedom. This will give you that critical value. How many standard deviations are you reaching out to be 95% confident? Well, there's 2.5% in each tail, and there's going to be 14 degrees of freedom. 16 minus 2, 14. So inverse t, 0.025, 14 degrees of freedom, n-2, and we are reaching out 2.14478. So my critical value is 2.1448, I'll say 2.1448 times the standard error of the slope, the standard deviation, basically. What's the standard deviation? And we call it the standard error of all the slopes, or of the sample. Okay, and that is given to us in our printout, the standard error of the slope. That is the 0.1993, the 0.1993, and you guys will have to grab that in your homework, that standard error of the slope. It's the 0.1993. Okay, so let's crunch it all out. The plus or minus the margin of errors, that's the 2.1448 times the standard error, 0.1993, and that is 0.427, plus or minus 0.427. Okay, so there's our confidence interval. And now I'll get the upper bound, the lower bound of that. Okay. So 1.30527 minus 0.427 is 0.878. And 1.30527 plus 0.427 is 1.732. Okay, so let's interpret the interval. Now, when you interpret the interval, you could say, like, we are 95% confident that the true slope of the regression line uh, for, a student's high school GPA and their freshman year college GPA is between 0.878 and 1.732. You could say it that way. We're 95% confident that the true slope of the regression line for students for their high school GPA and their freshman year college GPA is between 0.878 and 1.732. Okay. Another way that you often hear it is for your interval interpretation is to use the slope interpretation. So it's like this. We are 95% confident that for each additional x, so for each additional GPA point for your high school GPA, y, your college freshman year GPA will increase by the slope by 1.30527. Okay. Or no, excuse me, the interval. We are 95% confident that for each additional point of GPA for your high school GPA, for each additional X, your college freshman GPA will increase between 0.878 and 1.732 points. Done. Okay, I'll read that again. We are 95% confident that for each additional point of GPA you get for your high school GPA, your freshman year college GPA will increase between 0.878 and 1.732 points. And that is a 95% confidence interval for the slope. Okay, sorry about my handwriting. You can rewind it and hear me say it. Okay. Okay, great. So yes, positive slope there. What about the conditions? I'm not going to worry too much about the conditions. In Albert, they didn't really stress the conditions, but I'll just kind of tell them to you. But I don't think you ever really have to use them in the Albert assignment. But again, it's got to be a random sample. The data has to be linear, so you need to show a scatter plot. It's the straight enough condition. The data is linear. And then the nearly normal condition is for the histogram of the residuals has to be unimodal symmetric. But don't worry about that. The conditions, we won't really go into too much in depth with those conditions, okay? Okay, great. That's how you make a confidence interval. Just remember, big thing, how are you going to get the t-score for your critical value? Inverse t, and just remember your degrees of freedom is n minus 2 there. How are you going to get the standard error, the standard deviation of the slope? From the printout. Okay, it's on that slope line, standard error, and then go down to that line of the slope information, okay? Okay, let's do a hypothesis test really quick. And we're going to do now a linear regression t-test. Okay, what's the null? Okay, what is this test for? This is a test to see if the data is linear. Is there a linear association? Does the data make a line? Okay, and the null is always that there is no association, no linear association. And then the alternative, you could say that there's a positive linear association. It's going uphill, or you could say it's a negative linear association. It's going downhill, or you could say just that there's no linear association, like a not equal to two-tailed. Okay, so the null is always there is no linear association. There is no linear association between high school GPA and freshman year college GPA. And what we like to say there is that the slope equals 0 in parentheses. That's our null. Null is always no linear association. There is no linear association between high school GPA and freshman year college GPA. The slope equals 0. That's capital B beta. That's like the population slope. Beta equals 0. That means the slope equals 0. If there's no linear association, give you guys a little, right? Let's say there's no linear association, right? It's just randomly scattered. And then you have to put a line of best fit on it. The line of best fit, what does it have to do? The line of best fit has to minimize the residuals. So when you draw a line straight through just random points, it'll end up being horizontal-ish because these residuals have to be minimized. Okay, so that's the null, is that the slope of the regression line equals 0. There's no association. And then the alternative, and let's see what this one asks for. Is there evidence of an association between high school and first year college GPAs? So it doesn't say positive association. It doesn't say negative association. It just says in association. So I'm going to say there is a linear association. Keep out positive or negative. Sometimes it'll ask for a positive or negative, but the alternative, there is a linear association between high school GPA and freshman year college GPA. So in parentheses, the slope does not equal 0. And that's going to be your alternative. The null is always no association. And then the alternative is that there is a linear association. They do make a line. The points do make a line between the high school GPA and freshman year college GPA. The slope does not equal 0. And that can be greater than or that can be less than also for your alternative if it asks for a positive or a negative association, okay? Okay, great. Then you check your conditions. You know, it's a random sample. The scatter plot is linear. It has a linear form. The histogram of the residuals is unimodal symmetric. Great. Although don't worry about that. That doesn't show up in the Albert assignment too much. All right, so now let's get all our information. Let's get our p-value and stuff. And again, that comes right from the computer printout or from Linreg t-test on the calculator, right? Linreg t-test. Linreg t-test not equal to, bam, gives us line of best, gives the t-score, the test statistic, gives us the p-value, gives us the degrees of freedom. That's what we need. We're right there. The t-score, 6.548. The p-value, 1.3 times 10 to the negative 5. The degrees of freedom, 14. That's what they would have wanted on the AP test, right? And that was from our calculator, but you guys can see in the actual problem, all that information, right? That 6.55, that probability less than 0.0001, that's all in the printout also on that slope row, okay? And then the degrees of freedom. So what would we conclude? We would say with a p-value so low, 1.3 times 10 to the negative 5, with the p-value so low, we reject the null. There is sufficient evidence of a linear association between your high school GPA and your freshman year college GPA. So again, with a p-value so low, we reject the null. There is sufficient evidence of an association, a linear association between high school GPA and freshman year college GPA. And that is it. That's chapter 27. All right. Okay, that should hopefully help you get through that Albert assignment. Good, and we can do problems from that also in our Google Meets. Thanks, guys. This is it. This is the end. Last video. So again, make sure you read chapter 27. I feel like this video is a little scatterbrained, maybe my most scatterbrained video, but it's the last one. So and then we'll have time to talk through chapter 26 and 27 too. And then you guys will have 2 weeks to get all this done instead of 1 week. And this is only for the Mount Hood people. Great. Thanks, guys.